In 2002, every aerospace expert said reusable rockets were impossible. Today, SpaceX lands rockets on floating platforms in the ocean. This is the story of how one man's impossible dream became the future of space travel. December 21st, 2015. A Falcon 9 rocket launches from Cape Canaveral, delivers satellites to orbit, then does something no orbital rocket had ever done. It turns around, fires its engines, and lands vertically back on Earth. The SpaceX control room erupts in celebration. Engineers who'd worked for years toward this moment can barely believe it worked. Elon Musk, watching from mission control, allows himself a rare smile. This landing changed everything. For decades, rockets were expendable. You used them once, they fell into the ocean, and you built new ones. It was like throwing away an airplane after every flight. SpaceX proved rockets could land and fly again, and again, and again. Today, SpaceX dominates the global launch industry. They launch more rockets than any other company or country. They send astronauts to the International Space Station. They're building Starship, the largest and most powerful rocket ever created. But it almost didn't happen. SpaceX nearly went bankrupt 3 times. Experts mocked Elon Musk's ambitions. The first 3 rocket launches failed spectacularly. Success seemed impossible. This is the story of SpaceX, how a PayPal millionaire with no aerospace experience built the world's most successful rocket company, why everyone said it couldn't be done, and how they proved the impossible was just difficult. To understand SpaceX, we need to understand why Elon Musk started a rocket company in the first place. In 2001, Musk had just sold PayPal to eBay for $1.5 billion. He was 30 years old and extraordinarily wealthy. Most people would retire. Musk got obsessed with Mars. He believed humanity needed to become a multiplanetary species to ensure long-term survival. One planet meant one catastrophic event could end human civilization. 2 planets meant redundancy, backup, insurance for the species. But getting to Mars seemed impossibly expensive. NASA had no plans for human Mars missions. Commercial space didn't exist. Launch costs were astronomical, literally and figuratively. In October 2001, Musk traveled to Russia hoping to buy refurbished ICBMs to launch a greenhouse to Mars as a publicity stunt to inspire NASA funding. The meetings went badly. Russian rocket engineers saw a naive American millionaire and quoted outrageous prices. During the flight home, Musk did calculations on his laptop. He realized the problem wasn't rocket technology, it was cost. Rockets were expensive because aerospace companies had no incentive to reduce prices. They made cost-plus contracts where higher costs meant higher profits. What if someone built rockets differently? What if you manufactured most components in-house? What if you reused rockets instead of throwing them away? What if you applied Silicon Valley's rapid iteration approach to rocket engineering? In 2002, Musk founded Space Exploration Technologies, or SpaceX. The goal: reduce space transportation costs and make Mars colonization possible. Industry experts thought he was crazy. Aerospace veterans said you couldn't just start a rocket company. Established aerospace giants had decades of experience and billions in government contracts. But Musk had advantages traditional companies lacked. He was willing to take enormous risks, unburdened by legacy systems or bureaucracy and driven by a mission beyond profit. From day one, SpaceX's goals were audacious. Build affordable rockets, make them reusable, eventually send humans to Mars, and make humanity a multiplanetary species. Most aerospace startups failed. The few that succeeded took decades and government support. SpaceX would try to succeed faster, cheaper, and independently. Everyone said it was impossible. Musk thought impossible just meant really hard. SpaceX's early years were a masterclass in perseverance through repeated failure. SpaceX's first rocket, Falcon 1, was small by industry standards but revolutionary in approach. The team designed it to be as simple and affordable as possible. Musk recruited talented engineers from aerospace companies, offering them the chance to work faster and with more responsibility than traditional aerospace allowed. Many were young, brilliant, and willing to work insane hours for a mission they believed in. They set up operations in a former warehouse in El Segundo, California. No fancy facilities, no established infrastructure, just engineers, enthusiasm, and an impossible deadline. The first Falcon 1 launch attempt came in March 2006 from Kwajalein Atoll in the Pacific. SpaceX had spent 4 years and most of Musk's money getting to this point. The rocket lifted off successfully. Then, 33 seconds later, a fuel line leaked, causing a fire. The rocket crashed into the reef near the launch pad. Failure 1. But the team learned, modified the design, and prepared for launch 2. A year later, Falcon 1 launched again. This time, it flew for 5 minutes before the second stage engine shut down prematurely. The rocket fell back to Earth. Failure 2. Investors grew nervous. Media mocked SpaceX. Money was running out fast. By August 2008, SpaceX was nearly bankrupt. They had money for maybe one more launch attempt. This had to work. Falcon 1 lifted off beautifully. First stage worked perfectly. Stage separation succeeded. The second stage ignited. Then, 3 minutes into flight, the first and second stages collided. The rocket was destroyed. Failure 3. SpaceX was out of money. Employees wondered if they'd be paid. Musk faced the possibility of total failure. This was SpaceX's darkest moment. 3 failures. Money exhausted. Critics vindicated. The impossible dream seemed to be just that, impossible. Musk later said 2008 was the worst year of his life. Tesla, his electric car company, was also nearly bankrupt. He was going through a divorce. Both companies needed funding he didn't have. He had to choose, save Tesla or save SpaceX. He couldn't save both. Musk decided to give SpaceX one final attempt. The team worked frantically, analyzing the third failure, making modifications, preparing for launch 4. On September 28, 2008, just 6 weeks after failure 3, Falcon 1 launched again. First stage, perfect. Separation, successful. Second stage, ignition confirmed. The rocket kept flying. It reached orbit. Success. Finally, on the 4th attempt with their last money, SpaceX had reached orbit. The control room erupted in celebration. Engineers cried. Musk, watching remotely, could barely believe it. They'd done what experts said was impossible. Reaching orbit was just the beginning. SpaceX's real revolution was making rockets reusable. Days after Falcon 1's success, NASA awarded SpaceX a $1.6 billion contract to deliver cargo to the International Space Station. The contract saved the company. This validation from NASA changed everything. SpaceX had credibility. They had funding. They could develop bigger rockets. SpaceX developed Falcon 9, a much larger rocket capable of carrying significant payloads, and Dragon, a spacecraft for cargo and eventually crew. In 2010, Dragon became the first commercial spacecraft to return from orbit. In 2012, it became the first commercial spacecraft to dock with the International Space Station. SpaceX had proven they could compete with established aerospace companies and even surpass them. But Musk's real obsession was reusability. Disposable rockets made space access expensive. Reusable rockets could reduce costs by orders of magnitude. Everyone said it couldn't be done. Rockets experienced tremendous stress during launch. They traveled at hypersonic speeds. They heated to extreme temperatures. Landing them required impossible precision. SpaceX tried anyway. Early attempts were spectacular failures. Rockets crashed into the ocean. They exploded on landing pads. They tipped over on drone ships. Each failure taught lessons. Engineers refined landing algorithms, improved guidance systems, and strengthened landing legs. After years of attempts, on December 21, 2015, Falcon 9 launched, delivered satellites to orbit, then returned to Cape Canaveral and landed vertically. The landing was perfect. The rocket stood on its landing legs, intact and ready to fly again. SpaceX had achieved what the entire aerospace industry said was impossible. A rocket had gone to space and come back ready to fly again. 4 months later, SpaceX landed a Falcon 9 on a drone ship in the Atlantic Ocean. Landing on a moving platform in the ocean was even harder than landing on solid ground. They did it anyway. Today, SpaceX regularly lands and reuses rockets. Some boosters have flown over 15 times. Reusability has dramatically reduced launch costs. What once cost $200 million per launch now costs $60 million, and much less for reused boosters. This cost reduction has opened space access to more organizations and countries. SpaceX now launches more rockets annually than any other entity on Earth. They've become the world's dominant launch provider. SpaceX didn't stop with Falcon 9. They're building something far more ambitious. Starship, the largest and most powerful rocket ever created. Starship is designed specifically for Musk's ultimate goal, colonizing Mars. It's fully reusable, capable of carrying 100 tons to Mars, and designed to be refueled in orbit. The vehicle is massive, 50 meters tall when combined with its super heavy booster made of stainless steel and powered by up to 33 Raptor engines. SpaceX is developing Starship using the same rapid iteration approach that worked for Falcon. Build quickly, test, learn from failures, improve, repeat. This approach horrifies traditional aerospace engineers. Watching prototypes explode seems wasteful, but SpaceX argues that building and testing rapidly teaches more than years of analysis. Multiple Starship prototypes have exploded during testing. Some exploded on landing, others during pressurization tests. One spectacular failure saw a prototype explode during a landing flip maneuver. Each explosion teaches valuable lessons. SpaceX engineers analyze failures, identify problems, implement fixes, and test again. In April 2023, SpaceX attempted the first integrated flight test of Starship and Super Heavy combined. It was the most powerful rocket launch in history. The rocket lifted off successfully, generating incredible thrust, but several engines failed, the vehicle tumbled, and flight termination was triggered 4 minutes into flight. Traditional aerospace would call this catastrophic failure. SpaceX called it a successful test. They gathered enormous data, identified issues, and began improvements. 7 months later, Starship flew again. This time, stage separation succeeded. The booster completed its planned flight before being terminated. The upper stage flew for several minutes before also being terminated. Progress, not success yet, but clear progress towards the goal. Musk claims Starship will reach Mars this decade. Critics say that's impossible. They said the same thing about reusable rockets. Whether Starship reaches Mars on Musk's timeline or not, SpaceX is building capability that didn't exist before. They're making interplanetary transportation possible. SpaceX hasn't just built rockets, they've transformed the entire space industry. By dramatically reducing launch costs, SpaceX has made space accessible to organizations that couldn't afford it before. Small countries, universities, and startups can now launch satellites. This democratization of space access is enabling new applications. Global internet coverage through Starlink, Earth observation, climate monitoring, and scientific research. SpaceX's Starlink constellation aims to provide internet access worldwide using thousands of satellites. Over 1,000 Starlink satellites are already in orbit, providing service to remote areas without traditional internet infrastructure. This project was only possible because SpaceX can launch affordably and frequently. They're launching their own satellites on their own rockets, creating a vertically integrated space business. In May 2020, SpaceX's Crew Dragon became the first commercial spacecraft to carry astronauts to the International Space Station. For the first time, a private company was sending humans to space. This ended America's dependence on Russian Soyuz spacecraft and opened a new era of commercial human spaceflight. SpaceX's success has sparked competition. Blue Origin, Rocket Lab, and others are developing new launch vehicles. Traditional companies like ULA are working on reusability. This competition drives innovation across the industry, benefiting everyone. Perhaps most importantly, SpaceX has made space exciting again. Watching rockets land has inspired millions. Young people are choosing aerospace careers because of SpaceX. The company has proven that private enterprise can achieve what only governments could do before. SpaceX changed how people think about space. Before, space was for governments and billionaires. Now, space seems accessible, exciting, and full of possibility. This cultural shift may be SpaceX's most lasting impact, restoring belief that humanity's future includes the stars. So, what is SpaceX? It's a rocket company. It's a Mars colonization project. It's proof that the impossible is just really, really difficult. In 2002, when Elon Musk started SpaceX, everyone said reusable rockets were impossible. Orbital rockets couldn't land. Private companies couldn't compete with governments. Mars colonization was science fiction. Today, SpaceX routinely lands rockets. They dominate the global launch market. They're building the vehicle that could take humans to Mars. The company nearly failed multiple times. The first 3 launches were disasters. Money ran out. Critics mocked their ambitions, but they persisted. They learned from failures. They iterated rapidly. They kept trying when everyone else would have quit. SpaceX teaches us that impossible is often just a lack of imagination and persistence. What experts dismiss as fantasy can become reality through determination and brilliant engineering. The company also shows the power of first principles thinking. Question everything, start from fundamental truths, and build solutions from there rather than accepting conventional wisdom. Will SpaceX reach Mars? Will Starship succeed? Will humanity become multiplanetary? Nobody knows for certain, but SpaceX has already achieved things that were impossible a decade ago. They've changed space travel forever. They've inspired millions. They've proven that ambitious visions backed by brilliant execution can change reality. The impossible dream isn't impossible anymore. It's just the next engineering challenge. And if SpaceX's history teaches us anything, it's that they'll probably figure it out. The stars are closer than they've ever been. Thanks to one company's impossible dream, they're getting closer every day. Do you think SpaceX will reach Mars? Comment below. Subscribe for more tech documentaries.